are discussing about the electronic configuration of an atom, and I think we should continue with that. So electronic configuration is just an arrangement of an atom. Electronic configuration is just the arrangement of an atom within the shells around the nucleus. Arrangements of an atom within the shells So electronic configuration is the arrangement of an atom within the shells and the orbits around the nucleus. I repeat, so electronic configuration is the arrangement of an atom within the shells or in orbits around the nucleus. So every orbit has a very specific name. This is the nucleus, and we have an orbit around. This is the nucleus, and electron is revolving around the nucleus in one of the orbits. Every orbit has a quite specific energy. Every orbit has quite specific energy. Every orbit has the quite specific energy. The greater the distance from the nucleus, greater the distance from nucleus, higher the energy of the orbit. So every orbit has a quite specific energy. We have a distance from the nucleus, and they are which is directly proportional to the height. What does it mean that? This means that as far as the distance is increases from the nucleus, as far as the distance is increasing from the nucleus. I repeat, as far as the distance is increasing from the nucleus, the orbit gets a higher energy. I repeat, the distance, of course, the electrons are revolving around the nucleus. The electrons are actually revolving around the nucleus in one of the orbits or in one of the shells. In one of the orbits and in one of the shells. Higher the distance from the nucleus, higher the distance from the nucleus, higher will be the orbit or the energy. Higher will be the energy of the orbit. Now I just draw a three shells. Shell number 1, shell number 2, and shell number 3. Shell number 1, shell number 2, and shell number 3. Out of which the shell number 3 contain a highest energy out of these three. Then shell number 2 has a low energy, and shell number 1 has the lowest energy out of this. Shell number 1 has the lowest energy all of these. Why? Because it is closer to the nucleus. As far as it is moving away from the nucleus, as far as it is moving away from the nucleus, the energy will be increases. The energy will be increases. Electronic configuration, arrangement of an electron within the shells around the nucleus. So this is how the electrons are revolving around the nucleus, and every energy, every orbit has a quite specific energy. Every orbit has the quite specific energy. As far as the distance from the nucleus increases, as far as the or distance from the orbit increases, the orbit gets a higher energy. Now we get to know that every orbit is quite not the same. We get to know that every orbit is quite not the same. We have K, L, M, N. Shell number 1, shell number 2, shell number 3, shell number 4. Shell number 1, shell number 2, shell number 3, shell number 4. These are the shells that we have, like first shell, second shell, third shell, fourth shell. K, L, and M are just the representative letters of that shell. K, L, M, and N are just the represented at letters of that shell. Now, every shell has a quite specific capacity of accommodating the electron. Just like that, are different rooms in a house. In every house, the rooms are not quite the same. The capacity of the room is not quite the same. We have a one room which is quite smaller in number, like a storeroom. Then we have a kitchen which is small. Then we have a living room which is quite larger. The bedrooms are quite smaller. So every room has its specific capacity of having a people. Every room has its specific capacity of having a people. So just like that, every orbit has a specific capacity of accommodating the electron. It can, so the first shell, which is a K shell, it can accommodate a maximum of 2 electrons. It can accommodate a maximum of 2 electrons. Then we have a L shell. It can accommodate a maximum of 8 electrons. It can accommodate a maximum of 8 electrons. Then N shell, it can accommodate a maximum of 18 electrons. It does not mean that it is present in these electrons are present in this orbital. It can actually accommodate these electrons. As far as the electrons are being completed, they will stop accommodating. For example, we have a lithium. A lithium has an atomic number of 3. A lithium contains 3 electrons. So we have a first shell around the lithium. How many electrons it can accommodate? Of course, they have a 3 electron, but the lithium can accommodate only the 2 electrons. Then we have a next shell. How many electron left? Of course, they can accommodate 8 electron, but we can have only 1 electron. So what is the electronic configuration of lithium? 2, 1. Then we have an oxygen. Oxygen has atomic number of 8. Now we have a first shell, which can accommodate 2 electrons. Then we have another shell, which can accommodate 6 electrons out of 8 electrons. K shell, the first shell is present the 2 electrons, and then we have a 6th electron. So what is the electronic configuration of oxygen? 2 and 6. Is it clear to all of you? About this is how the electronic weekend represents the arrangement of an electron in an atom. Then we have a chemical bonding. The chemicals combines with each other. The chemicals actually combines with each other. Why they combine? Because they wanted to gain stability. Because they actually wanted to get stability. Atoms. Now, what is the stability for an atom? What is the stability for an atom? An atom is called as a stable. An atom is called as a stable when he has 8 electrons in their outermost shell. An atom is called stable when he has 8 electrons in their outermost shell. I repeat, an atom is called stable when he has 8 electrons in their outermost shell. As we can see, I have multiple examples. We have a calcium. This is the outermost shell. It contains the 2 electrons. This is the outermost shell and it contains the 2 electrons. Is it stable? No, he wants to get stable. Then we have a sodium. The outermost shell is that. Is it containing 8 electrons? No, it contains 1 electron. It is not stable. So every atom is not stable and he wants to get stability. And what is the criteria of stability for an atom? 8 electrons in their outermost shell. 8 electrons in their outermost shell. This is the criteria for stability of an atom. How would get, okay. Now the next, what are the types of chemical bonding we have? Ionic bonding. We have a covalent bonding. Then we have a metallic bonding. A coordinate covalent bonding. We have a three types of, or the three major types of the chemical bonding: an ionic bonding, a coordinate covalent bonding, a covalent bonding, and a metallic bonding. Let's start one by one. The first, we have an ionic bonding. Ionic bonding is basically the combination of, now the ionic bonding is basically the combination of ions. How the ions are being formed? The ions are being formed by the gain and the loss of electrons. Ionic bonding is basically the combination of ions. What are the combination? How the ions are being combined? By the combination of ions. Ions are being formed by the gain and loss of electron. Ions are being formed by the gain and the loss of electrons. Let me explain clear. Let's say we have a sodium. A sodium and outer shell contains 1 electron. What is the criteria of stability? Of course, they wanted to have an 8 electrons. Let me know, because the sodium contain only 1 electrons, he wanted to gain 8 electrons he must have an 8 electrons. What he do? Either he have to gain the 7 electrons, either he has to gain the 7 electrons, or either he has to lose 1 electron. Can you let me know which one is quite easier? Can you let me know which one is quite easier? Either sodium contains a 7 electron. Let me write the 2, 8, and 1. This is the electronic configuration of a sodium. And we have the 1 electrons in the outermost shell, and you wanted to have one. Either we can gain a 7 electron, or either we can completely lose that 1 electron, so we can have an 8 electron in the valence shell. Of course, the loss of 1 electron is quite easy, because the gain of 7 electron is quite difficult. The gain of 7 electrons is quietly difficult. The gain of 7 electron is quietly difficult. So a sodium lost its 1 electron, and the sodium will convert it into sodium ions. The sodium will eventually convert it into sodium ions, Na positive. In the similar manner, we can also have a chlorine. We can also have a chlorine. The first shell of a chlorine has a 17 electron. The first shell contains a 2, then we add, and then we 7. Now it can easy to get a 1 electrons. So the chlorine gains 1 electron and convert it into chlorine negative. We have a Na positive by the loss of 1 electron. Both of them, the reason for both of them quite same. Both of them wanted to gain stability. Both of them actually wanted to gain stability. The reason for both of the particles is quietly the same. Both of them wants to gain. Now, as one have a positive charge, the other have a negative charge. So both of them, one have a positive charge, the other have a negative charge. So both of them can actually have electrostatic force of attraction between the electrons. So this is called as an ionic bond, the bond between the ions. Is it clear? Is it quite clear?
सर अभी मैं थोड़ा समझेगा तो क्लास आप एपिसोड है मेरा इसी के टाइम पर
This is the ionic bond. The next we have a magnesium. Electronic configuration is magnesium 282. And then we have a magnesium actually lost 1 electron. So we have Mg2 positive. Then we have an oxygen, we have a 2 and 6. It actually gains the 2 electron in order to form an 8. So O negative. So a bond is being formed between these two atoms. So this is called as an ionic bond. Have you cleared that?